Hello again, everyone. Dr. Tom McNamara here, back for our course in college algebra, continuing to talk about rational functions. In our last couple of videos, we discussed the unique features that these kind of functions have. In particular, vertical asymptotes. As we can see here on Desmos, I've got the graph of I'll feel better if it looks like this. F of x equals 2x plus 1 over x squared minus x minus 6. We've got the graph over here, and we notice it has three disconnected pieces. And the reason that's happening is because the denominator, as we can see here, it factors. The denominator factors into x minus 3 times x plus 2. So this function has vertical asymptotes at x equals -2 and x equals 3. Let me go ahead and maybe change those to dotted lines, because they're not really part of this function's graph. They're like boundaries on this function's graph. Okay, maybe I'll make both the asymptotes blue. All right, done. Okay, so the function has vertical asymptotes there. Those are vertical lines that the function cannot cross. In this video, I wanted to talk about horizontal asymptotes for these rational functions. And we can see here, this function's graph flattens out rather quickly at the line y equals 0. The bigger x gets, the closer y gets to 0 as we go off to the right. And similarly over here, the more extreme negative values also produce y values that are getting increasingly close to 0, progressively closer to 0. So this function has a horizontal asymptote at the line y equals 0. Now the line y equals 0, of course, coincides with the x-axis. And the reason that we are seeing a horizontal asymptote at y equals 0, because it won't always be at y equals 0. The reason we're seeing a horizontal asymptote at y equals 0 is because my numerator for my rational function is a degree 1 polynomial. Okay, it's a linear polynomial. Whereas my denominator is a second degree polynomial. So the denominator has the larger degree. So horizontal asymptotes, it actually breaks up into three cases. Let me switch over to the document camera. So when we're dealing with horizontal asymptotes, we have three cases to look at. And the case we're in right now, case 1, the denominator has a higher degree than the numerator. In that case, you will have a horizontal asymptote at y equals 0. And why is that happening? What's going on? Well, the denominator is growing at a much faster rate than compared to the numerator. So in our example, the numerator involved x to the first, the denominator involved x squared. Okay, so for large x values, let's say x equals 1,000, the numerator is about 2,000. Let me go back to my function so we have it here. If I use a large x, like x equals 1,000, the numerator is about 2,000. Well, I go into the denominator, that's going to be 1,000 squared, so that's 1,000,000. So the numerator is 2,000, the denominator is 1,000,000. Denominator is much bigger. If I use an even bigger x value, let's say x equals 1,000,000, my numerator is about 2,000,000. Denominator would be involving 1,000,000 squared. 1,000,000 squared is 10 to the 12. I don't even know what to call that. We'll just call it 10 to the 12. Okay, so the fraction is going to be on the order of about 10 to the minus 6. That'd be 0.000001, approximately. Okay, and the bigger x gets, the more exaggerated that is going to be. And the reasoning is, if you have a fraction with a big denominator, compared to the numerator, that means the value of your fraction is near 0. Okay, so the bigger your denominator gets, the smaller your fraction gets. And think about think about some small numbers. Take a half and compare it to a quarter. A quarter is less than a half. You got 1/10. Well, that's less than either of those two. One out of 100, that's even less. So the bigger the denominator gets, the smaller the fraction gets. And when we have a scenario where the denominator has a higher degree, it's going to grow faster, and hence the fraction's value is going to go to 0. Now, this isn't always going to be the case. You won't always have the same degree, top and bottom. Let me do this. Okay, so we put x squared up top. Notice the graph is no longer flattening out towards y equals 0. So I have 2x squared over x squared minus x minus 6. Notice I still have vertical asymptotes in the same place, because the vertical asymptotes come from values of x that make the denominator 0. I changed up the numerator so that these two guys have the same degree. And we see it's no longer a horizontal asymptote at y equals 0. This guy is having a horizontal asymptote at y equals 2. Okay? Let me change my settings a little bit. And my y-axis, I want to go from not negative 10 to positive 10. Let me do negative 20. Oh, no, shoot. My x-axis, negative 10 to 10. Let me change my x-axis. Let me go from negative 20 to 20. And I bet we'll see it a little better there. See how this graph is flattening out? It's almost indistinguishable from this horizontal line that I've put in here at y equals 2. Okay, so this is case 2 for dealing with rational functions and figuring out their horizontal asymptote. So case 2 is when the numerator and denominator have the same degree. And of course, we remember that when we're talking about a rational function, we mean a fraction with a polynomial up top and a polynomial on the bottom. And the degree of a polynomial is the highest power that appears in the expanded version of the polynomial. So in the case we have right now, we have 2x squared over x squared minus x minus 6. So the top is degree 2, the bottom is also degree 2. In that case, you will have a horizontal asymptote at the ratio of the lead coefficients. Okay, so in our case, y equals 2x squared over x squared minus x minus 6. The horizontal asymptote will be at 2 over 1. Lead coefficient up here is 2. Lead coefficient down here is 1. And as we see in the picture, the graph is flattening out towards the line y equals 2. So I still want us to understand why this is happening. And the reasoning is basically the degree determines the rate of growth for large x values. So the numerator and denominator grow at similar rates. So let's say I take a big x value once again. Let's say x equals 1,000. Okay, well my numerator is 2 million. Because I take 1,000 squared, I get 1 million. So my numerator would be 2 million. my denominator would be about 1,000,000. I know we're subtracting some stuff. Okay, so we're subtracting 1,000. Big deal. Got $1,000,000, you lose $1,000, you have 999 or you have $999,000, which is still basically $1,000,000. Okay, so x equals 1,000. Numerator is basically 2,000,000. Denominator is basically 1,000,000. That's basically 2. X equals 10,000. Numerator is 2 times 10 to the 8. Denominator is basically 10 to the 8 still. Okay? So when you have the numerator and denominator having the same degree, you get a horizontal asymptote at the ratio of the lead coefficient. So I bet you can guess what the next case is going to be, right? We have denominator larger degree, same degree, and I guess we should do the third case where the numerator has the larger degree. Okay, let's see what happens when we examine a case like that. Let's go back to Desmos. Let me hide these for right now. Tell you what if I'll just bump it up, 2x cubed. Okay, I really need to zoom out to see what's happening. Okay, notice I still have my vertical asymptotes there, but this graph isn't flattening out anymore. Okay, let me change my view here. Let's go with x being minus 20 to 20, and y being, I don't know, minus 50 to 50. I bet that'll give me a nice view of what's going on here. Okay, so this graph isn't flattening out to a horizontal line. In fact, this is actually flattening out toward the line y equals x. Let me turn that on. Oh, no. Sorry, y equals 2x. Okay, it kind of flattens out and becomes more and more like that. Now, a horizontal asymptote, as the name implies, is a horizontal line. Just like a vertical asymptote is a vertical line. Remember, mathematicians are not creative with names. A vertical asymptote is a vertical line. A horizontal asymptote is a horizontal line. So, as we can see in this example, in this scenario, we will not have a horizontal asymptote. Okay, so the three cases that I want you to remember for horizontal asymptotes are you could have a horizontal asymptote at y equals 0. You know you're in this case if your denominator has the bigger degree. You could have a horizontal asymptote at the ratio of the lead coefficients, and that'll happen when your numerator and denominator have the same degree. Or you could have no horizontal asymptote. So if the numerator is bigger, your graph will not have a horizontal asymptote.